the second fundamental theorem of calculus. And I want you to integrate those so that you believe the theorem. So the phones should all be put away. And we're going to integrate that and differentiate it. Maybe somebody wants to come up and do it. Because you guys know how to do this. Yeah. Pardon? Yeah. But do you believe it? Oh. So, I mean, I can do it. Because I want you to believe it. Okay, what's the integral of t cubed? T to the fourth over 4. What's the integral of 2t squared? 2t cubed over 3 plus 4t. Okay? Now we want to differentiate that. Oh wait, I gotta do the fundamental theorem. So it's x to the fourth over 4 plus 2t, whoops, not t. It's 2x cubed over 3 plus 4x minus all these numbers. 1/4. What happens to c? Because if you do plus c, then this is going to be plus c, and then will be minus c over here. It'll cancel. Minus 1/4 minus 2/3 minus 4. Now I'm going to differentiate again. I mean, just think about it. We integrated, and now we're going to differentiate. Where should we be? Where should we be? Back at where we started, right? Mm-hmm. I'm sorry, what? No. Nope, no need to write that. So what's the derivative of this thing? Well, the 4's cancel out, so I'm left with x to the third. The 3's cancel out. I'm left with 2x squared plus 4. It's the same as taking this x and putting it in there for c. It should make sense. If square rooting undoes squaring, and squaring undoes square rooting, you get back to x. Well, you got to be careful about that one. I really get the absolute value of x. I'm hoping you remember it. But I also want you it to make sense. Last year you might have memorized it. This year it should make sense. What happens on problem 2? Well, we're going to integrate. But it isn't x. It's x cubed. So it's x cubed cubed. Now, when I taught at the University of Minnesota, and they taught out of this book, not quite done, they never gave any problems like that. However, on the test, that was a 25-point problem, they had a problem just like that. Well, of course, the students hadn't done anything like that. So they put in x. They didn't put in x cubed. That was one problem. But some of them thought to put in x cubed, but it's still not done. Why? Because if you were to integrate it, but if you were to integrate it, you'll have function of x cubed. So when you differentiate, you must multiply by the derivative of the inside function. Well, guess what the inside function is? It's right there. What do you do with the exponents? Now, if this is free response, leave it. If it's multiple choice, you're going to have to do it. So this is what? X to the, we multiply these because it means x cubed times x cubed times x cubed, which is x to the 9th. So this is 2x to the 6th. No, we shortened it. Because what is the derivative going to do to the integral? It's going to cancel it out. Well, I'm going to do it in general. So let's see why this works. Is that okay? Okay, guess what? I can't integrate those. Anybody in here have a CAS calculator? Oh, you could borrow mine. I don't have it on my iPad. I have a regular Inspire on the iPad, which is unfortunate. But anyway, if I do it with a CAS calculator, I try to integrate that. Actually, that one can be integrated. You'll learn how to integrate that one by parts. It's complicated. But then you have to differentiate. So why do all that work just to differentiate? All you do is put in x for t. So it's e to the x times the cosine of x times the derivative of x, which is 1. Remember it? Then help me out and tell me why you guys struggle with this. Because it is easy. It should be easy. Maybe it's so easy you can't believe it that that's what we have to do. Is that what it is? I mean, it could be. These things, Eric, undo each other. So this x cubed goes right in here. And so we're going to get 1 over the square root of what? Now, if it's free response, honestly, I would write it this way and not simplify, because I saw some simplified wrong, times the derivative of this. Done. If it's multiple choice, you are going to have to multiply it out. Yes. Okay, you guys? The lower limit must be a constant because when I go back here, this is the lower limit. I don't care what the constant is. When I differentiate that constant, it goes away. If it's in the wrong order, and why does the order matter? Let's go back to our first one, because it teaches a little differently than last year, because you do know this. Why does it matter that it's 1 to x? Because it's this function minus the constant. If the constant's the upper limit and the x is here, then these will switch. And this is subtraction. It's not commutative. That's why it matters. So if you're clever, you can make up your own corollaries. The corollary is a theorem that follows from a theorem. Okay, Eric, please put your phone away. Not right now. Okay, let's go through the theory here. Let's do, we don't have to do both of these. Let's do this one. Okay, guys? Let's say the integral of f of t dt is capital F of t, and there should be a c because it's indefinite. Okay, guys? So I have the derivative with respect to x of this integral of f of t dt. Well, that's capital F of t. Using the fundamental theorem of calculus, I will evaluate it here. Okay? Nick, question? So it's d dx, and it's capital F of g of x minus f of 1. And then we are going to take the derivative. That's just a fundamental theorem. I integrated and evaluated that antiderivative at the upper limit minus the lower limit. So now you can see why the order matters more clearly. What's the derivative of capital F? It's f prime of g of x. That's correct. Times what? The derivative of that inside function because it's composite. What's the derivative of my constant, no matter what it is? It's minus 0. That's a constant. What's the derivative of a constant? 0. Well, this is f of g of x times g prime of x. And I promise you will see this on the exam. Ask. First I did the integral of f of t right here, made a big f of t. Then I used the first fundamental theorem, or the evaluation theorem, and evaluated my function at the upper limit minus evaluating at the lower. Then I took the derivative back again, and you should think it will cancel out, and it does. The only problem is that I now have a composite function here, and I must multiply by the derivative of that upper limit. And just some other little properties. I don't think I have any typos. So what happens if we reverse the order of integration? The integrals become negative. Sorry, that should be an A. I don't know if it's written on yours correctly or not. Right. What if f is an odd function? And you go minus a to a. That's 0. What if f is even? You can't get rid of it. But you can make it a little easier. Oh, sorry. Yeah. Okay. I don't know. Is yours typed right? No, so you fix yours. That's not right unless you want to write odd next to it. Okay. There are just a couple little properties. And then I think we should do problem 30 together, because every year everybody wants to skip it. And unfortunately, with problem 30, that is the problem that was on the exam a couple years ago. Some variation of it. So, yes. I'll get that, and then I'll let you guys work, and I'll mark it off and get it back to you. These properties, okay, if you are going to major in math, you're going to see stuff that looks like that. It's not as bad as it looks if you read it. This just says that if my y value is positive, then what's true? What is an integral, by the way? It's a signed area. I know, even I get lazy. I just want to say it's the area under the curve. But if the function's always positive, what's with the signed area? It's always positive. Okay, it looks terrible to read that. But that's the math people creating symbols so they don't have to write all the words. Honestly. Now, this is saying f is bigger than g. Okay, guys? Here's f. And I only care about the interval. Here's g. Then what's true about the signed area under the curve? It's logic. That's right. This area is larger than this area. There you go. The next one is the kind of the tricky one, and it has to do with the mean value theorem. Well, it's the average value, and it'll come into play, but we can do it now. It looks terrible, but let me try and draw this. Wait a minute. Can I move that? I want you to, it's problem 30, I believe. I'll double check in your assignment. And the assignment's not that long. We're spending one day on this section. Good. Okay. Okay. That's the G area and the F area. Sorry, it looks weird. The area under G is less than the area under F. I don't care if it's negative or not. F is bigger than G. Okay, so I'm going to draw some function in here. Here's f of x. I am going to go from A to B. And it just kind of begs to do the average value, the mean value. Now, do you believe that the area under the curve, if I talk about areas, that's a continuous function? So if I take the area here, call this y value little m, isn't the integral, I'm going to rewrite what I have, from A to B of f of x dx, isn't that the actual area bigger than the area onto that rectangle. And what is that rectangle? It's m times b minus a. Make sense? This area under my rectangle, under my curve, is bigger than the green area. Yep. This would be the maximum. We're just doing rectangles. It's a comparison. It's a comparison here. Okay. Now, what's true about the area under the curve relative to the red area? It's smaller, right? So this area here is trapped between the area of the green rectangle and the area of the red rectangle. That's all it's saying. So I'll tell you, if this area here is 2 and this area here is 8, then you know the value of your integral should be somewhere between 2 and 8. They get this one. They test this one on the multiple choice. It's very subtle. So if it makes sense to you, that's how you're going to remember this. So I know the area is 2 and the area is 8, and then they give you an answer saying the integral must be 10, and I know it's trapped between 2 and 8. I'm going to throw that answer out. There are some of those weird ones. You might even have to use like the mean value theorem or something to do that. But, well, since we're kind of here, because I just can't not do it, do you believe that the area is continuous? If the area is trapped between this value here and this value here, does it not pick up all values between 2 and 8? Yeah, it does. It picks on all values. Can I draw another rectangle where it's equal? Do you think that there's some place in here that the area of my rectangle is exactly equal to the integral? Yes. The area that you start from here to here, that's a continuous function. Areas can't just jump from 2 to 8. So we'll call that C. So then that means that the integral from a to b of f of x dx has to equal, there's got to be some rectangle in here. If the area is 2 and the area is 8, then all these rectangles you put under there have to pass from 2 to 8. Every single value. I should be able to draw a rectangle that's equal to any number between 2 and 8. Well, in particular, it's f of c. And the area is base of b minus a. You solve for f of c. And you guys recognize this because I taught it. What is that? That's the mean value theorem for integrals. That's average value. Oh, good. Perfect timing. Couldn't be better. Okay, this is the average value of a function, which I just did yesterday, but there it is. It's the mean value theorem. Okay, there's f. We didn't scale it exactly right. Okay, David? How do I find g? What is g? What does this mean? It's the signed area under f of t. Okay, you guys? Matt? Chris? Okay. Well, the first part's easy. By the way, this first part of the question was easy. You got a point on the exam for this. It wasn't the same question, but it was almost the same thing. So I want the area from 0 to anything less than 0. Well, what's the area under this curve right here? That's 0. Okay, so you got a point for that on the exam. Then I want the area for anywhere in between 0 and 1. How do you do that? Integrate what? I can, but is the area equal to the area of the triangle at that point? Is the area, how are you going to find this area? You're going to integrate what? F of t, not from 0 to 1, from 0 to where? That doesn't give me the area of this triangle. If I integrate f of t from 0 to 1, it gives me that big green triangle, doesn't it? So I have to get this one, where this line, I'll see if it works, will move all the way through here. That's variable area, isn't it? So I have to integrate from 0 to x. This area, let me change the color of that line. Let's make it purple, just so you can see it. Okay. Now, this line, I want to find the area of each one of these little triangles till I get here. So if I stop halfway at 2.5, which is 1, it's half on my 0 to 1. That's the area of that triangle. If I integrate from 0 to 1, I've found the area of the big triangle. Yeah. So we have to integrate it. I know this is 1, so this is 0.5. The point is, you can't integrate from 0 to 1. It's variable. So this is from 0 to x. This was t dt because they're dummy variables. I should be about it because they will be proper in college. Isn't that right? It was x, so it's t. So it's t squared over 2 integrating from 0 to x. So what's that answer? X squared over 2. That's why this is hard, because you have to think a little bit. Okay, so this is x over 2. No, I want to find the area, no matter where x is, between 0 and 1. Oh, thank you. You're right, x squared over 2. Okay, it gets a little trickier yet. Now I want to find the area from 1 to 2. It's a piecewise function. But if you're thinking here, this is why I want you to do this. I think tomorrow we'll do the snow problem, because it's the same question. Now you got 1 point. Well, there were only 3 points on this. Okay, now I want to find the signed area over here. But there is something that's always constant. The area of the triangle. This isn't changing. So what is the area of that? That's 1. That's 1. So the area of the triangle, I don't like my grid, is 1/2 base times height. So it's 1/2, you're right, plus this integral. Where are we integrating there? It's the integral starting where now? Yes, it's starting at 1, and it's going to go up to x. Because each one of these little trapezoids is different. I want the area from 0 to over here where that purple line is. That yellow area is the same, and this is going to change. So it's the integral from 1 to x of my function, and you probably will use x's. That's okay, it's not quite correct, but it's this 2 minus x. But we're going to make them t so I don't get confused with my variables. Then you integrate that. Is that okay or no? Okay, because I'm going to add the triangle, and I'm not starting at 0. I'm starting at 1 for this particular function. So it's 1/2 plus this antiderivative is what? 2t minus t squared over 2, evaluating where? 1 and x. I have a definite integral, the c's won't be there. Because if I put plus c here and I subtract, the c's will go away. So it's plus 2x minus x squared over 2. Okay, this is what I'm putting in. Minus 2 minus 1/2. Is it easy to make a sign mistake? Well, it is for me. This is 2x, and I'm going to do this, what I call it slowly. So it's minus 2 plus 1/2, and I don't like to do fractions particularly. So what's 1/2 plus 1/2? And 1 minus 2 gives me a minus 1. So the answer, if I check the back of the book, oh, there is no answer in the back of the book, but it should be minus 1. So let me put it up in the spot up here. It's 2x minus x squared over 2. Okay, now that you know a lot there, what is the area under the curve from 0 to 2? From 0, well, I'm sorry. Yeah, because my integral is from 0, right? It's 0 to 2 now, to do this piece. It's 1 because you're going to have the first triangle and the second triangle, and nothing changes after that, does it? So it's 1/2 plus 1/2, which is 1. Should have it right. Ask me. I heard I was still confused on something. Remember what g of x is. It's the area from 0 to x. So to do the area from for this function, I have to add in the first triangle. So it's 0 to 1 and then 1 to x. That's why I like the snow falling problem, the removal problem. I don't know why they call it snow removal. Why can't they just say they're shoveling the snow like we say? But if you were from Hawaii, that might be a problem. They do have snow in Hawaii. Did you know that? Where do they have snow in Hawaii? On the mountains. I didn't see it, but that doesn't mean it. Okay, now, Alex, you want to graph that? Is it right now? G, which is the area starting at 0. Oh, we'll call it, yeah, pick a color. You can go up here and pick a color. You can use a crayon, too. There's a crayon. But here's the colors. No, you have other crayons. There. They don't show up really well. You're trying to graph G. What is G? Oh, it's G the area? It's the area, yeah. So actually, it might be easier to graph that. So he's going to explain it. It's a crayon. You see why I don't use the crayons? I like them. So the area here is 0, and the area is growing, growing, it's growing, and it's growing, it's maxing out, and then it's going to what? It is still increasing. Are there any places where f is, let's reframe the question. It's asked if f is differentiable. Are there any places where f is not differentiable? Yeah, I think so. No, the crayon curve. Where is f not differentiable? X can't be where? Where can't you take the derivative of f? 1, where else? 0 and 2. Is g differentiable everywhere? Yeah. You know why you know? Because they give you the derivative defined everywhere. Even though the derivative's got some corners, we don't care. G. G is the area. It's differentiable. You can put your name on it? So there are some other problems on there that are challenging. This is not easy. They are not easy problems. Okay, I don't give you the easy ones. You know, I might give you a problem like 7. Fairly easy, though. And actually, I don't think there's really anything particularly easy. Definitely try 28. Oh, no, 28 says a cast. Never mind.